Let's take a look at the transformations that can occur to a parent function. Graphed in red is the parent function of absolute value. We can graph absolute value functions that look similar to the parent function, but are graphed in different places on the coordinate plane by transforming it. If we make changes to the coefficient in front of the absolute value bars, that will change its steepness and whether or not it's reflected. If we make changes to this h value inside of the absolute value bars, that controls movement left or right. If we make changes to this number k outside the absolute value bars, that controls movement up or down. So let's look at some examples. Y equals negative absolute value of x is the exact same as the parent function in red, except it's flipped. Instead of all the y's being positive, all the y's will be negative. This graph is exactly the same as the parent function in red, except it's shifted up 2. This one is exactly the same as the parent function, except it's shifted right 4. Let's take a look at two slightly more complicated examples. In this purple equation, there are 3 things happening. 1, this function is flipped, shifted left 2, and shifted up 1. So it's still going to be a V shape, except it'll be flipped, left 2, up 1. Notice how it went left 2 and then up 1. And it's flipped, so now it points down instead of up. Let's take a look at the blue equation. This one is shifted right 3 and down 4. So starting at 0, 0, I see I'm going right 3 and down 4 to plot my new point. It's not reflected, so it'll just point up. In summary, changes to the coefficient outside of the absolute value bars controls the steepness and whether or not it is flipped or reflected. Changes to h, the value inside the absolute value bars, will shift the function left or right. Changes to k, the value outside of the absolute value bars, will shift the function up or down.